Hey guys, in the previous videos we learned how to calculate the enthalpy change. In this video we will be learning how to calculate enthalpy of formation when enthalpy of combustion is given to us. Let's go over the question first. Octane is C8H18. This means the liquid state. One of the major components in gasoline burns completely with oxygen to produce carbon dioxide and water vapor. This type of reaction is called combustion reaction because if anything burns in the presence of oxygen and releases carbon dioxide and water vapor, it's called a complete combustion reaction. The molar enthalpy of this reaction, because it's a combustion reaction, so that's why they said that the molar enthalpy of combustion reaction of octane is negative 5074.1 kilojoules per mole. Determine the molar enthalpy of formation of octane if these two delta H naught F's are given. Now first we need to write on the reaction. So we know C8H18 liquid in the presence of oxygen gaseous would give carbon dioxide that is present in a gaseous form plus water vapor is also present in a gaseous form, and we are given delta H for this reaction, and that is delta H naught C, combustion reaction, is negative 5074.1 kilojoules per mole. Per mole means for 1 mole of octane. Now if we balance this reaction, we see this reaction is not balanced. We see there are 8 carbons, so if I put in 8 carbons here, I would get how many oxygens? 8 times 2 16 plus 1 17 oxygens. I have 2 hydrogens, I have 18 hydrogens, so I would put 9 there. Now if I calculate my oxygens, I have 8 times 2 16 plus 9, that is 25 oxygens. So all I would have to do is I would have to put it as 25 over 2 because I cannot disrupt this number because this is for 1 mole and then this is given to me as well as, and delta H naught C is also given to me as 1 mole. So now we know delta H naught F is a formula. So in this case, delta H of this reaction is sum total of number of delta H naught F of products minus sum total of number of moles of delta H naught F of reactants. We are given this because delta H here is nothing but delta H naught combustion. We are given delta H naught F of water, so this is given. We're given delta H naught F of carbon dioxide, this is given. We are looking for this. Now again, we are given nothing for this. This is oxygen, and I told you in the previous video that if anything is present in its natural state, like oxygen O2 gaseous is in its natural state, so for this the delta H naught formation is 0. Okay, let's first calculate delta H naught F of products. Our delta H naught F for products is, because products are carbon dioxide and water, and then how many carbon dioxide molecules are there is 8, so we do 8 times negative 393.5 plus 9 times negative 241.8. So this is for the products. Minus what is the sum total of reactants enthalpies. Reactant we don't know for octane. So 1 times the enthalpy of octane, that is C8H18, plus oxygen is 0. This side we know is negative 5074.1. So when we put this on the calculator, we get negative 3148. Put this on the calculator and we get negative 2176.2. And this is minus delta H naught F of octane. We're looking to solve this. So all we have to do is just isolate it. So I'm going to move this here so it becomes delta H naught F of octane. I'm going to put this on the calculator. I get negative 5324.2. And I move this over. I get plus 5074.1. That gives me 250.1 with a negative sign because the bigger number is negative kilojoules per mole, and that is the heat of formation of 1 mole of octane.